my 7th grade advancers. Let's go ahead and work these problems. I got number 7, the practice of problem solving. It says triangle QRS prime is the image of triangle QRS after a reflection across the y-axis and a translation of 6 down. So we're saying that this here is a this one, this prime, or the original image, pre-image, reflected across the y-axis, which would be over here, and then brought down 6 units. Is the image the same size and shape as the pre-image? It says triangle QRS and QRS prime blank, same size and shape, and that's pretty simple. They are the same size and shape. All right, let's move to the next one for me. That's number 9. Describe a way to show a quadrilateral ABCD is congruent to ABCD prime. Well, the pre-image is over here. So I see that this is 1, 2, 3 blocks away from Y. So is this one 1, 2, 3. So that tells me that D, we could reflect this across and put D over here. And we could put A over here. And we could put B over here. And we could put C over here. Okay? And it's important to label. That way we know which ones are where, right? A, D is over here. And then B. And C is over here, right? And then when we connect these, that'll give us here to here, here to here, here to here, and here to here. Okay? Now, so I could say I reflected it, and then I went down. You see how A matches up and D matches up? I can say I went down 1, 2, 3, 4, 5. So I'm going to go ahead and say reflected across the y-axis. And translated down 5 units. Okay? Units. Sorry about that. Should be units. There we go. All right. Okay, I guess my next one's number 11. Let's go down to number 11 now. Let's see here. Number 11 says, which 2 triangles are congruent? Describe the sequence of transformation that maps one figure to the other. I do got 11, right? Yes. Okay, so which ones are congruent? All right. Let's see. Well, I know that this angle here from R to Q, okay, is, let's see, it goes up 1, 2, 3, 4, 5, and over 2. So it has a slope of 5 over 2. Okay? So let's see which one would be congruent to this. We could say that this angle here is also 1, 2, 3, 4, 2, 3, 4, 5 over 2. So that angle of F and D matches this one. This one over here, which is the opposite side, will be 1, 2, 3, 4, 5 up, and 1, 2, 3. And this one is 1, 2, 3, 4, 5 up, and 1, 2, 3. So this angle matches it. And this last angle here, the last side, excuse me, is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So when we're talking about congruent, I will say that R QS or RSQ is congruent, looks like, to EFD. Okay? Let's see if any of the others are congruent. To do that, I would match these again. This kind of looks like it might be this one. Remember, this was 2 and 5. If we look at this one, wow, this is kind of off here because this triangle is kind of cocked at a weird angle here. We need to find one that's going to go over one and up one. There's none like that over here. This one over here would have to go 2 and 3 off-centered, or 2 and 1, 2, 3, 4. This one goes 1, 2, 3, 4, 5. This won't work. This also does not match this one. That's obvious by the base not matching E and F. I gotta say, I think because A, B, C, D does not match these two, and I don't think X, Y, Z matches these two either, because this is an isosceles triangle. These definitely aren't. Neither is this one. I think the only two that we can't say are congruent are these two. It looks to me if we did RQS maybe clockwise, let's see, if we did it negative 90 degrees clockwise or 270 degrees counterclockwise, then we would have this one 2 away from this side, just like this would be. Let's see here. And then if we reflected it as well, let's see, that would bring this here. I think we would have to bring that over and then reflect it as well to make that match. The only problem is I think we're going to have a problem after we get it over here. We could say we're bringing this here, and then we'd probably have to reflect it across R this way, and then bring it down. So one way you could do this is to state, let's see, we could say we're going to rotate QRS. I should put triangle QRS. Do this the correct way. Triangle QRS. Across the x-axis. Okay. And then, let's see, reflect it. Let's see, reflect. Across point R. And then translate it down 5 units. Okay, that's one way to do this. Let's see here. Another way we could do this is quite the opposite. We could take EFD, okay, and then rotate it 90 degrees. Let's see, reflect it, and then let's see. Well, actually, if we reflected this here, and then Actually, we should have rotated it. Yeah, we rotated it, QRS across the x-axis. Actually, that should have been rotated. Kind of change that. Rotate QRS negative 90 degrees around the origin. Sorry about that. Okay. And I really messed that up, didn't I? Origin and reflected across the y, reflected across point R, and then translated down 5 units. Or we could go ahead and rotate, let's see, we could also rotate E or DEF, triangle DEF. 90 degrees around the origin. And let's see, once I did that, then this would be here, right? And it would be pointing up, but this would be the wrong side because this triangle would be here. So we could reflect it across E. Let's see. Across reflect it across I guess we could say point E, but that would be really, because E would be here, we could say across 2, right? Where X is 2, across line X equals 2. And then, let's see, translate it 5 units to the right. Okay? Those are 2 ways off the top of my head I could think of doing it. Right? I don't know if I can make a triangle like this to show you guys how that would be, but let's see. Let's see if that's gonna let me turn it. Yeah, that's kind of right, eh? There we go. Uh-oh, moving the figure, sorry about that. There we go. So we'd have kind of this going on. Put that there. Not quite sure how to angle this right. Let's see. If I turn it more like that, will it work? Yeah, it's kind of like that. Let's see if it'll let me drag this. Nope. Trying to get it to where you can move the line, but if you see this got rotated, right? 90 degrees, that would put it about like that over here. Oh boy, this thing just wants to move every time. There we go. Okay, and then it would be on the opposite side, and then we'd have to flip it, right? So we'd have to bring this side over here. Nope, not letting me really do that, is it? Oh, frustrating. I want to be able to demonstrate to this to you, but it's really giving me a lot of issues. Oh, flip. Left to right. Not going to do it. Flip. Left to right. Nope, doesn't want to. Okay. Um, yeah, not really doing what I was hoping I was going to do. And turn this in the opposite direction. If it did, that would make it really easy to demonstrate, but of course not everything is going to be easy like you want it to. Nope, nope. There's no part of this in this program that lets me do that. All I can say is it's going to turn it this way, and then it'll fit more like this. But it'll be over here, and then it would have to move it 5 units to the right. Okay? So that's what I was trying to demonstrate. I hope you got a little bit of an idea of what I was talking about. Whoa, that one totally south. All right, there we go. All right, let's go to the next one. That was number 11, so number 13 is mine. Howard thinking question. Whew. Well, this one says a student was asked to describe a sequence of transformation that maps pre-image DEF, that would be this one without the asterisks, to DEF prime. Given that triangle DEF is congruent to DEF prime, they look pretty much the same. She incorrectly said, so there's something was wrong, huh? The sequence of transformation maps DEF to DEF prime is a reflection across the x-axis. So they're saying they reflected it across here, okay? I'm going to try to use that shape again and see if it works out this time. I don't know if it's going to really pay off, but I'm going to give it a shot. looks about like that. So let's turn it. Okay. There we go. That worked out nice. Okay. And we're saying they're reflecting across the x-axis. So we're taking this and bringing it over here. So this has to be one away from here, right? It's going to be the opposite. So let's see. I wonder if the flip rotate's going to work on it this time. Flip up and down. Oh, look at that. That worked good. So if I flip it this way, remember, E is going to be touching over there. So this is actually going to look more like this. And this is going to be here. And since this is 1, 2, 3, 4, and then one up, this has to be 1, 2, 3, 4, and one up. So I'm going to have to turn this just a little bit more this way. Okay. There we go. All right, now this is a reflection of this, and that even shows me 1, 2, 3, 4, and one up over here. 1, 2, 3, 4, and one up here. This perfect reflection. All right. Now it's saying across the x-axis, followed by a translation of 6 units right and 4 units up. So 6 units right would be 1, 2. Wait a minute. This is actually left, isn't it? 1, 2, 3, 6 units right would be going this direction. And then 4 units up. 1, 2, 3, 4. Let's make sure. 1, 2, 3, 4. Actually isn't going to reach as high. I think what they wanted to do was make it to the left instead of the right. 1, 2, 3, 4, 5, 6. So 6 units to the left, maybe. That would put it about here. And then 1, 2, 3, 4 up. That might work. Let's see. Yeah, 6 units to the right. 1, 2, 3, 4, 5, 6. So it should really be 6 units to the left, and then 4 units up. 1, 2, 3, 4. So that's the mistake there. What mistake did she make? It looks like what she did was she brought this one over to the right when it should be to the left. So she should have translated 6 units to the left and 4 units up. Okay? And that would have fixed it. All right, I think that's all the ones I had. So the rest of yours to do. Good luck on the rest of them, and I'll see you in class.